In the equations above, b and c are constants. If b is c minus 1 over 2, which of the following is true? Keeping in line with what we've been practicing, we can establish that this equation right here is a system of equations problem. Just that's the concept. And we can approach it on trying to solve the system of equations. You want to eliminate one of the variables, and we can do that any number of ways. One of the ways is just to add these down or subtract them. So why don't we actually focus on that? We can subtract everything. Like those would be subtracted, these would be subtracted, these would be subtracted, and those would be subtracted. So let's go for that approach. We would have 3x minus 3y, and then plus b minus c, and that should equal, the other side is 5x minus 5y plus negative 7 minus 7, which becomes a plus 7. And by the way, this plus and minus right here, we might as well just change that to a minus, because that's what happens when you have a positive sign next to a negative. So that rearranges this system of equations just using that one fact. Now you might be wondering, why did we opt to use subtraction rather than multiply this whole top equation by -1? That's just a shortcut. You could do that if you wanted, but it's just quicker to do it this way for this type of problem. Why? Because we have too many unknowns, x and y, and then b and c. Now, we were also given some bonus information that b is c minus 1 over 2. So we can write an equation using that information. b is b equals c minus 1 over 2. So when we glance over at the answer choices, what are we looking at? We're looking for what statement is true. So what is being said in the answer choices 1 through D, we can see that there's something that's consistent throughout. X is y minus something, x is y minus something, x is y minus something, x is y minus something. So that's a sign that we need to isolate x. In other words, x's need to be on one side and everything else on the other side. However, before we can even take advantage of that idea that we just found out, is here we have b equals c minus 1, and we are noticing in the equation that we came up with is a b minus c. So I think it would really help us if we rewrote this b minus c to be if we wrote this equation, this b equals c minus 1 over 2, to look like b minus c. And all we need to do is just subtract c from both sides. And notice that we now know that b minus c is simply negative 1 over 2. We can plug that into our equation. So what would we have? We would have 3x minus 3y. This b minus c is actually negative 1 over 2. That's what we just found out. Equals 5x minus 5y. And guess what? This negative 7 plus 7, those cancel out too. Those are gone. So that's what we have. Now we've already established that we need to get the x's on one side. Why don't we do that? Let's subtract 3x from both sides as shown. And what's going to happen is that those cancel. We now have negative 3y minus 1 over 2 equals 2x minus 5y. So we're getting closer. Since we want x to be by itself, we need to get rid of this 5y. And we can add 5y to both sides, like so. Rather, I should write it really under this 3 so it looks better. And we can see that the negative 3y plus 5y is 2y minus 1 over 2 equals 2x. And to get x fully by itself, we just need to divide each thing by 2. So divide this by 2, divide this by 2, divide this by 2. So on the right side, we thankfully can cancel out these 2's, and we finally have x isolated. So here you have negative 1 over 2 divided by 2. Of course, this is the calculator section, but just as a reminder, if you're dividing complex fractions, you can do outside multiplied So -1 times 1 is just -1 over the inside multiplied. So that's really -1/4. So we know that this part is -1/4. And then these twos cancel. So here we go. You have it. X, I'm going to rewrite this beginning with x equals to y minus 1/4. And that appears to be choice A.